Today we're going to cover the structural analysis of a medium maple cello. The purpose of the study will be covered, as well as the assumptions, data gathered, boundary conditions applied, structural results, and any closing remarks. The purpose of the study was to understand how the strings of a medium maple cello cause a deflection on the front face of the cello. It was considered to be an average maple cello with 4 strings, and we averaged 10 different cellos for the 4 strings. The front face was also assumed to be fixed along the edges. The data gathered was such that the maple wood properties were an average material properties, and the EX direction was along the length of the cello, as well as a typical string tension were averaged. The typical geometry was used for a medium maple cello. As you can see here, these are just standard cello dimensions for the bridge and the string angle. The average force per foot was calculated to be 36.64 pounds using basic trigonometry. The boundary conditions that were applied were the pressure loads at the location of where the feet would exist, as well as the rigid structure along the outer edges. The structural results indicate that a maximum deflection of 154 thousandths of an inch would be generated from the string tension, which is 0.158 inches, or roughly 4 millimeters, and the stress in the cello due to the string tension was within material properties. The closing remarks are that the front face of the cello deflects 4 millimeters under standard string tension loading, and the maximum stress generated is within material properties. Here's a summary slide of all the key design criteria for this project.